How you going, Year 10? We're back with another video about nonlinear relationships. Today, we're doing a bit of a deeper dive into exponential graphs. Okay, now the important thing to recognize firstly is what is the difference between an exponential graphs equation and a parabola or quadratic equation. So we notice here the equation for an exponential is y equals 2 to the power of x. Okay, or it could be 3 to the power of x, it could be 10 to the power of x, or anything like that. It's just that x is in the power. Okay, the unknown, the thing that changes as you go along the x-axis is the power. Okay, and that's an exponential graph. A parabola, okay, has a quadratic equation where x is the base, and then you've got a squared as the power. So 2 is the power in this case. Now these look very similar, okay, but they're quite different shapes. They behave quite differently. It's important that we can see the difference between a parabola and an exponential. So that's the first thing that we need to get over, okay? So let's do the graph of y equals 2 to the x. The way we're going to do this again is we just want to do a little bit of a table of values, okay? So x and y, and let's just start at -2. We'll go to -1, 0, 1, and 2, and see what happens, okay? So if we have x equaling -2 in this particular exponential, okay, then we're going 2 to the power of -2, and that will give us our y value, because y equals 2 to the power of x, and our x value is -2, and we get 0.25 or 1/4. Okay, and then when x is -1, we can just make that a -1. We get 1/2. And then when x is 0 to the power of 0, we should know that anything to the power of 0 is 1, okay? Because anything divided by itself is 1. That's what 2 to the power of 0 means. Because if you had 2 to the 1 divided by 2 to the 1, okay, you subtract the powers, you get 2 to the power of 0, okay? So 2 divided by 2 is 1, and so 2 to the power of 0 is 1. It's the same with anything that's to the power of 0. And then 2 to the power of 1 is just going to be 2. And then 2 to the power of 2, we should know, is just going to be 4. And we get this interesting pattern here where we have this sort of symmetry. We have 1 in the middle, and then we have 1/2, and then 2 on the other side. We've got 1/4, and then 4 on the other side. This kind of symmetry, or upside down symmetry, if you will, for an exponential. Okay, so what this graph will look like is at -2, we've got a quarter, we've got a half, okay, then we go to 1, and then we go to 2, and then we go to 4, and we can see we've got this sort of like ramp shape graph, and it never passes this x-axis, and then it goes up very steeply like that. So if I was to put in x as -1000, okay, you see that it rounds to approximately 0, but it never gets below 0. If I make this 1 billion, or just a big number, it never gets past this value. Now it doesn't actually equal 0. It gets very close to 0, but your calculator rounds it down to 0 because it doesn't have enough space to do a bigger decimal there. Okay, so that's our little ramp shape for our exponential. Remember the ramp shape when you're drawing these, okay? What happens if we change the equation, okay? So we're going to make it y equals 2 to the -x, okay? Y equals 2 to the -x. So all we're doing is changing the x value to become its negative. Let's see what happens. Okay, so again, we're going to do the same values, -1. So basically, what's going to happen here is we're going to change the sign of the x value. Okay, so if it was negative, it becomes positive, and we're going to get this mirroring effect. Let me show you what I mean. So 2 to the power, oh, not 22, 2 to the power of -2, which is the same as just +2, is going to equal 4. Okay, and then 2 to the power of -1 is just 2 to the power of 1, which is just 2. and then we get 1, and then we get 1/2, 1/4. So you can see here, it's the same as the graph we had before. We've just swapped the values of y with the different signs of x. Okay, instead of getting the value of y for -2, what it was before, is now the value of y for +2, and the value of y for +2 is now the value of when x is -2. So we get this kind of swapping effect where the ramp is now going up this way. Okay, and it doesn't go below the axis there. It sort of flattens out very quickly, and then it shoots up the other side. We can see this kind of mirror image of the graph that we had before. So adding this minus sign in front of the x value, all it does is swap, okay, the values of x and y, of x, sorry, so that what was the value of y when x was positive is now the value of y when x is negative, and vice versa. Okay, what happens though if we change the graph to y equals -2 positive x? Okay, so this time we've got a positive power. We've just times the whole thing by -1. So let's do our little quick table of values. And we don't actually need a calculator for all of this. We can kind of make this or work this out in our head. So just by using the values that are in the one before. So when x was -2, okay, I had y equals -4, equals 1 on 4. All we're going to get now is y equals -1 on 4. We're just timesing our final answer by -1. So when x is -1, okay, we're going to get -1/2. When x is 0, we're going to get -1. When x is 1, we're going to get -2. And when x is 2, we're going to get -4. So we've just changed all our y values from the above graph to its negative. And so this one, instead of being above the x-axis, we're just going to get all of our values below the x-axis. Okay, so we've got a ramp, but this time it's sort of an upside down ramp going like this. We put arrows on either end to show that it keeps going. So we've made a mirror image this time over the x-axis. So before, when we had our second graph, it was a mirror image over the y-axis. Now we've got a mirror image over the x-axis. So the question is, what is this graph going to look like? -2 to the power of -x. Now, I want you to actually predict here. Stop and think, pause the video if you need to, and just think, what do I think this graph will look like? You don't need to do a table of values. Just think by the effect of what we've done, what the shape is going to be. Okay, and just think, okay, what happened when I made it -1 before? What happened above? What happened below? So have a look at all those and then make a prediction. Okay, unpause the video when you've done that and then see how you go. What I'm going to do my table of values just to show you. Actually, what I'm going to do is do the graph first and then do the table of values to show that you don't actually need the table of values to predict the shape. Okay, I'm going to predict that it's going to be a ramp shape going this way. Okay, like this. So what I've got is a mirror image of the one to the left across the y-axis, but it's a mirror image to the one above it across the x-axis, okay? So the -1, the minus in front flips it this way, okay? And the minus in the power flips it horizontally. So you got the vertical flip by timesing it by -1. You got the horizontal flip by changing the x value to minus, okay? Now let's do the table of values just to confirm that I'm right here. So we've got -2, -1, 0, 1, and 2. And we're just picking those values there just because they're around the middle and they can give us an idea of the shape. So that's why I'm picking those numbers in my table. And then my y value, okay, let's put this in our calculator. We've got -2 to the power of -2, which gives us -4. Okay, and you can see here, that's what I had here, -2, -4 on my graph. Let's change this value to 1. We get -2. And then change the value to 0. We get -1. And you can see it's the same values as we had above here, except all of them have become negative. Okay, just like we had before. Okay, so what we need to be able to do is notice the difference between timesing it by -1 out the front. Okay, so this one gives us a vertical flip. Okay, mirror image over the x-axis, so it's flipping vertically. And then this minus, okay, gives us a horizontal flip. It's flipping over the y-axis horizontally. Okay, that's what we need to remember about exponentials. All right. Last thing we're going to look at is just simply if I have y to the 2x, but then I add 2. Okay, basically what's going to happen is instead of it flattening out on the x-axis, it's going to flatten out just above the x-axis. So I'm going to get my crossing my intercept, rather than being at 1, we're going to plus 2 to that, and it goes through 3. And then instead of going through the value 1, 2, it's going to go through the value 1, 5, and then 2, it's going to be up here, and this is going to flatten out just below, or just at y equals 2 here. If we want to prove that, okay, let's just chuck in a value here. Let's go, so that's just 2 to the positive x, by the way, sorry, not minus x. 2 to the -2, and then plus 2. So we get this 2.25. You see, it's a quarter above 2 this time, rather than a quarter above 0. And that gives us that shape there. If I have y equals 2 to the x minus 2, it's going to be the same graph, just shifted down 2. So you're going to have this intercept at -1 instead of being at 1. You're going to have something at 1, 2. So instead of being at 1, 2, it's going to be at 1, 0. Then instead of being at 2, 4, it's going to be at 2, 2. And you get the idea from there, and this time it's going to flatten out just above -2. Okay, so you see it's the same graph, we just shifted it down to, or as before, we shifted up. So this shifts up, but it doesn't change the shape, doesn't flip it, it just shifts it up. And then this -2 is going to shift it down. Okay, so we can see just by altering these exponential equations, we change the shape of its graph. We need to match the features of the equation to the features of the graph. Okay, you need to get good at noticing these. It helps to have a good intuitive understanding of what you're doing, rather than just rote learning this. Really try to understand why it flips, okay, or why it shifts based on the alteration that we've made. All right, good luck with the work today. I'll see you later.